So now we're going to talk about making predictions based off of what we know with our probability. So in this first example, in a bag of 40 jelly beans, there are 5 skunk spray jelly beans. So we can use that ratio of 5 skunk spray jelly beans to 40 jelly beans to answer the following questions. How many do you predict will be skunk spray in a bag of 40 jelly beans? Well, we can set up a proportion of using the ratio of 5 to 40 from what was stated in the beginning, and do x are unknown to a bag of 80 total jelly beans. Again, we can cross multiply and solve this. We get 40 times x, get 40x, 5 times 80 to get 400, and then we know that there are, when we divide both sides by 40, we get 10 skunk spray jelly beans. Again, we could have easily seen that 40 times 2 gives me 80, so 5 times 2 would give me 10. That is definitely something we can do if we can see this factor which we're increasing by, but we want to practice setting up those proportions in case we don't see that right away. So how about in a bag of 160 jelly beans? So again, using that ratio of 5 skunk spray to 40 jelly beans is equal to x, or our unknown, to a bag of 160. So we're going to cross multiply, so 40 times x and then 5 times 160. So we get 40x is equal to 800, and then divide both sides by 40, we get x is equal to 20. Looking at example 2. So here, Nemo was playing in a soccer game last weekend. For every 8 times he shot the ball, he scored 1 goal. So his ratio here is 1 goal per every 8 shots. So we have 1 per 8. Okay, so keeping that ratio in mind. So how many goals can he predict to have if he shot 96 times? So setting up that ratio of 1 to 8, set that equal to our unknown variable to 96. So 1 over 8 is equal to x over 96. Again, and we're comparing shots we're making to the goals we are making out of the total shots in the denominator. So when we cross multiply, we get 8x is equal to 96. Divide both sides by 8. And Nemo scored 12 goals, or we can predict that he will score 12 goals if we continue with this pattern. Now, what if he only shot 50 times? Well, instead of shooting 96, let's see what happens if he only shot 50 times. Well, we're going to use that ratio of 1/8 from the beginning and set that equal to x over 50. Now we can cross multiply this to solve, so we get 8x is equal to 1 times 50, and then divide both sides by 8 to get 6.25. When we get 6.25, we're going to say, because you can't make 6 goals in a quarter of one, so we'll say he made about 6. Now, this time, if he wants to score 6 goals, keeping with the ratio of 1 goal for every 8 shots, okay, how many shots should he take? Well, we can still use a ratio of 1 to 8, but this time we know that 6, okay, is our numerator because that's how many goals he wants to make. We're trying to figure out how many shots he should take on goal, and so that's going to be our denominator. So this time we're going to cross multiply. 1x is equal to 8 times 6, so x is equal to 48. So he needs to attempt 48 shots in order to make 6 goals. Again, C was all about understanding where to place the 6, and we know 1 goal, and he wants 6 goals, so 1 and 6 should both be in the numerator. And then 8 is how many shots he's been taking, and x is the unknown number of shots he should take if he wants to make 6. Now let's look at number 3. Ria and Sia have a bag with 3 purple marbles and 4 blue marbles. They are going to randomly draw from the bag 280 times, putting the marbles back in the bag after each draw. So they're going to take one out, they get a color, place it back in, so they still have 280 in the bag. So they will draw a purple marble. In order to determine whether A, B, C, or D is the best answer, let's look to see what would happen, or using the probability of purple, because that's what they're asking for. So here we have 3 purple and 4 blue. So that means I have a total of 7 marbles, so I have 3 purple for every 7. And we're trying to figure out how many will be purple out of the 280. So that's how we set up a proportion. Again, that 7 comes from the total number of marbles because we're going to pull out a total out of the bag 280 times. So here you're going to cross multiply. You get 7x is equal to 840. Then divide both sides by 7. You get x is equal to 120. Now we need to keep in mind that this right here, that's 120, represents our theoretical. So our theoretical is 120. So we can go ahead and eliminate C and D because it's not going to happen 160 times. Now reading carefully here, A is saying it's going to be exactly 120 times. So out of the 280 times they pull out of the bag of marbles, it's going to happen every time they do it 120 times. It's going to be purple marbles. B is saying, okay, so it should be close to 120, but probably not exactly. Okay, and remembering what we talked about experimental, okay, theoretical is what should happen, what we expect to happen, but in our experiment, that's not always the case. So the best answer here is B. Okay, it should be really close to 120 because 280 is a large number, but it won't probably be exact. So now let's go ahead and look on the back side. And just a reminder, predictions should always be based on the theoretical probability. Experimental probability is only calculated when asked. So you need to read the questions carefully again. We're always assuming it's theoretical we're referring to unless we're using the information based on the table, based on the data, based on what's happened. Okay, those are all key phrases for experimental. So Andrew flipped a coin 200 times. Here are his results. So out of 200 times, landed on heads 153, tails 47. So if he flips a coin 500 times, how many times should he expect to land on tails if based on his results? Keyword here, based on his results. So right there, that's information that we want to use experimental. Okay, so we want to refer to the table, not to the theory of landing on heads one time and landing on tails one time. We flipped it exactly twice. So here, setting up a proportion, we have 47 tails from the table, a total of 200. They said it was 200 times that the coin was flipped by Andrew. So then x over 500. Now, let's go ahead and cross multiply to solve this. So we have 200x is equal to 47 times 500, which is 23,500. Now we want to divide both sides by 200 and we get x is equal to 117.5. Again, it's a decimal, so we can just say it's about 117 times, or about 118.5 is right in the middle. Now, looking at B, if they were to complete the experiment 10,000 times, how many heads would you expect him to flip? Nowhere in this question does it state that we're going to look at the experimental, we're going to look at the results. It's just saying, what would you expect him to flip? So that's theoretical. So I have 10,000 times. There are two different outcomes, so over 2. So that means it should happen 5,000 times to land on heads. So exactly even 50% of the time. Looking at number 5. Maddie is waiting at the bus stop and she watches 5 cars pass her. 2 were yellow, 1 is green, 1 is orange, and 1 is red. What is the experimental probability of a red car driving by? Well, there was 1 red car out of 5 total cars, so 1/5. Based on what already happened, what's the experimental probability that the next car is red? Well, the next car is going to be red 1/5 of the time, based on the experimental again. Based on what has already happened, if 100 cars drive by, how many do you predict will be yellow? Again, that first phrase there, based on what's already happened, that means we're still using the information of what Maddie observed. So to be yellow, yellow was 2 cars out of 5, and then x over 100. So we're trying to figure out how many yellow will there be if 100 total cars drive by. We're going to cross multiply. 5x is equal to 2 times 100, which is 200. Divide both sides by 5 to get 40. So based on what's already happened, 40 cars should be yellow. Looking at number 6. Esteban spun the spinner 60 times and landed on the shaded region 42 times and the unshaded region 18 times. What is the experimental probability of landing on the unshaded region? So here we have one unshaded and the rest of these blues are shaded. So here, because it's asking for experimental, we're going to look at the information in the problem given to us. So unshaded was 18 times out of 60. So now we can go ahead and simplify that. When we simplify that, we simplify all the way to 3/10, which is 0.3 or 30%. And again, either of these options at the end would be an appropriate answer. Now for B, Esteban spun the spinner 800 times, and how many times would you predict he would land on the shaded region? So here we're looking at theoretical because it did not say to refer back to the data. It did not explicitly say experimental. So we're going to look. Shaded region, there's 1, 2, 3, 4 shaded out of 5 total spaces on the spinner. Set that equal to x over 100. Now we're going to cross multiply. We get 5x is equal to 3200. And when we divide both sides by 5 to get x by itself, we get 640. So if we're predicting this, we are saying 640 times out of 800 should land on the shaded region.